Hello everyone, welcome you all to this new video. So till now we have covered a lot of concepts from module 2, that is image transform. So one more concept which is very important, and there are high chances that they might be asking this question also, that is related to the HAAR transform, okay, or the HAAR matrix. So how this matrix HAAR transform HAAR matrix works. So in detail with all the conditions we are going to see two of the important problems for 2 point and 4 point development of HAAR matrix, that is 2 cross 2 HAAR matrix and 4 cross 4 HAAR matrix, how it is obtained. One by one we are going to see it in detail. Okay, HAAR transform, the HAAR functions, that is hk of x, so this is one HAAR function, are defined on a continuous interval. Okay, so the HAAR transform is defined on a continuous interval, it is not discrete in nature. From a continuous interval the HAAR transform is picked and it is defined, that is where x belongs to 0 comma 1 for k equal to 0 to n minus 1, and where this is the continuous interval and n is equal to 2 power n. Okay, the integer k can be uniquely decomposed as k is equal to 2 power p plus q minus 1. So this equation you need to be remembering very carefully, because this is one very important equation which you need to be remembering for obtaining any of the HAAR matrices. Okay, where the value of p would be between 0 to n minus 1 and q is equal to 0 or 1 for p is equal to 0, and the value of q would be in between 1 to 2 power p for p not equal to 0. Okay, for example, when n is equal to 4, so this is the value obtained, that is k is equal to 0, 1, 2, 3 based on this equation. So the value of p would be 0, 0, 1, 1 and 0, 1, 1, 2. That is first, in the first case you see here 0, 0, 0. If you substitute all these zeros in this equation, it won't be getting, the LHS would be equal to RHS. Okay, similarly if k is equal to 1, then you should be taking the values of p as 0 and q as 1. Okay, if we take p is equal to 0 and q is equal to 1, then only this equation would be getting satisfied. And if we take the value of if k is equal to 2, then you should be taking the values of p as 1 and 1, and if k is equal to 3, you should be taking the value of p as 1 and 2. Okay, these are the only set of values which would be satisfying the equation k is equal to 2 power p plus q minus 1. Okay, so hope it is clear. And this is the HAAR functions and how it is defined as, you see here they have given it. This is very important, guys. The HAAR functions are defined as h naught of x, that is h of 0 comma 0 of x, okay, that is equal to 1 by root 10. Okay, this is 1 by root 10 where x belongs to 0 comma 1. Only for values 0 and 1 the this condition would be getting satisfied, that is it is equal to 1 by root 10. Else for the value hk of x, that is other than 0, when it is 0 it is 1 by root 10, and if it is other than 0 the value is given by h comma h of p comma q, where it is equal to 1 by root 10 into we have three factors here. Okay, not one. First is it is equal to 2 to the power p by 2. When it is equal to 2 to the power p by 2, when x lies between q minus 1 divided by 2 power p and q minus half divided by 2 power p. Okay, when x lies between this term, okay, then only it would be equal to 2 power p by 2. Okay, and it is minus 2 to the power p by 2 when x, that is this value, lies between q minus half divided by 2 power p and q divided by 2 power p. Okay, if it is not satisfying these two intervals, then the third interval value would be equal to 0, that is the direct answer we would be getting it as 0. Okay, so these are the conditions for HAAR transform. So this is one simple example. So I have that numerical. Let us see that. First, steps to obtain matrix. Okay, steps to obtain matrix. You see here they have given it here. So this is the general formula. T is equal to HF H transpose, where H is the HAAR matrix, F is the n cross n image matrix, and T is the resultant transpose. Okay, these are the basis functions as I've told you here. The same thing. Okay, the same thing is given here. Now steps to obtain matrix. You see here. Basically the basis function represented as hk of z. Okay, so this is the basis function for z belonging to 0 comma 1. Only for the value 0 and 1 this it is represented, and k is represented as from 0, 1, 2, 3 up to n minus 1. Okay, and the value of k is given as 2 power p plus q minus 1. And further, if p is equal to 0 and comma q is equal to 0 or 1, you would be getting this condition here that we are going to see in a later part. For each ith row of the matrix, that is hi of z, it is calculated as z is equal to 0 by n, 1 by n, 0 by n comma 1 by n up to n minus 1 by n with respect to whatever value of n it is. Okay, so since if the value of n is 2, then the sequence would be from 0 by 2, 1 by 2, and so it would be terminating to 1 by 2 because we have n minus 1 by 2, that is 1 2 minus 1 by 2. So there it would be terminating, and based on the n values you would be getting the number of values. Okay, so that let us see with one problem now. So with this problem it will be very very clear how to solve the HAAR matrix. Okay, so this is the problem here. You see here they have given it as find 2 cross 2 HAAR matrix H2. Okay, so they have told us to find the H2. So these are the steps here. You see here, since 2 cross 2 transformation matrix is asked here, the value of n would be equal to 2. Okay, that is the we know we have an equation which you have already seen for HAAR matrix, that is n is equal to 2 power small n. 2 is equal to 2 power small n. So if we solve it, we would be getting our final small capital and small value of n as 1. Okay, so now you see here we have got small n as 1. Since they have asked for 2 cross 2 matrix, so this is the 2 cross 2 matrix build here, and the z value would be ranging from 0 by 2 and 1 by 2, and k value is either 0 or 1. Okay, so these are the set elements which is present in the HAAR matrix, that is h0 of 0 by 2, h0 of 1 by 2, h1 of 0 by 2, h1 of 1 by 2. Okay, so these four elements you need to be finding one by one. Okay, since the z equation is 0, 0 by n, 1 by n up to n minus 1 by n, and in this case the value of n is equal to 2, so you will be getting the values of z as 0 by 2 and 1 by 2. Okay, so we cannot be writing 2 by 2 because the final term is n minus 1 by n, that is in this case it is 2 minus 1 by 2, that is 1 by 2. So here we have only two values of z. Okay, that's why you have written it here, and k is equal to where k tends from 0 to n minus 1, and this is the k equation here, that is 2 power p plus q minus 1 for all the values of k, that is 0, 1, 2, 3. What and all are the values you should be taking for p and q? They have mentioned it here. That is, if you want the value of k to be equal to 0, p and q you should be taking it as 0, 0. For k equal to 1, it would be 0, 1. For k equal to 2, it should be 1, 1. And for k equal to 3, it would be 1 and 2. Okay. If you take this set of values, then only it would be satisfying this equation. Okay. So with this, we have written this matrix here, H2. Now you see here. First is H0 of 0 by 2 and h0 of 1 by 2. Okay, these two values, since it is present in the first row, for the value of k equal to 0, you should be writing directly that is equal to 1 by root 10. Okay, for if you consider for any of the HAAR matrix, the first row elements, okay, either it be 2, 3, 4, the first row elements are same, and the first row element formula is given directly as 1 by root n. Okay, since in the formula only they have given it like that, you see here, h0 of x, that is h0 comma 0 of x is 1 by root n. Okay, that is for the first row elements it is 1 by root n and it is fixed. Okay, so that's why h0 of 0 by 2 and h0 of 1 by 2, for both if you substitute it, that is the 1 by root n, so n value is 2, so 1 by root 2. So for both the values h0 of 0 by 2 and h0 of 1 by 2, it is 1 by root 2. So now these two values are over, we have got it, that is 1 by root 2. So now these two values are left. So how to calculate that? You see here, it is easy to calculate, nothing much to do. First is h1 of 0 by 2, okay, and h1 of 1 by 2. For that you should be checking for the formula, this formula here which we have written it here. Okay, first in that we have three set of intervals. Okay, first you see that intervals, that is first interval is from it is 2 to the power p by 2, when the first interval is from q minus 1 divided by 2p, and z lies between is less than or equal to z, which is less than q minus zero point 0.5 divided by 2 power p. So here in this case we should be taking the value of q as 1. Okay, why you should be taking the value of q as 1? Because our k value here it is 1, right? In both the cases it is 1. Since k value is 1, we should be taking the values of p as 0 and q as 1. So that's why we have taken the value of q is equal to 1 here for the first interval. So 1 minus 1 divided by 2 to the power 0. Again, I've told you p value should be equal to 0. That's why they have taken it as 2 to the power 0 less than or equal to z less than, again substitute q, that is 1 minus 1 by 2 divided by 2 to the power 0 is 1. So 1 minus half. So 1 minus half is, again it is equal to half. So it would be 0 by 1, that is 0, and half divided by 1, that is 2 to the power 0 is 1. So this is the range of z, that is z lies between 0 and 1 by 2. Okay, it is strictly less than 1 by 2, so this is not less than or equal to, it is less than. Okay, so this is for one first interval, that is here I have written it directly, that is z is between 0 and 1 by 2. Okay, and second condition that is the second interval condition is q minus half divided by 2 power p less than or equal to z less than q divided by 2 power p. So here you see here the value of q, again you should be taking it as 0 and p as 0 and q as 1, because the value of k here is equal to 1 in both the cases. So that's why you see here they have taken the value of k as they have taken the value of q as 1, that is 1 minus half divided by 2 power 0, and here they have taken 1 divided by 2 power 0. So 1 minus half is half, divided by 2 power 0 is 1, and 1 divided by 1. So half by 1 is half, and 1 by 1 is 1. So next, this is the next range of z, that is from z lies between half and 1. Okay, so so this is the H2 matrix condition, that is it is equal to 1 by root 10 into 2 to the power p by 2 for z ranging from 0 to half. It is minus 2 to the power p by 2 for z ranging from half to 1, and it is 0 otherwise. So now let us calculate H1 of 0 by 2, that is this term. Third element, H1 of 0 by 2, that is 0 by 2, again it is equal to 0. So the equation is 2 to the power of p by 2 divided by root 10. We are taking the first condition. Why? Because you see here the z value is 0, right? The z value is 0, and in these two intervals it would be satisfying only the first interval 2 to the power p by 2, where z is between 0 and 1 by 2, right? So here the value of z is 0, so that's why it would be in this interval. So we should be taking this as our equation here. Okay, so 2 to the power p by 2 into, so this would be getting multiplied, right? So that is why we have written it as divided by root 10. So 2 to the power p by 2. So again the value of p, since the k value is 1, we should be taking it as 0. 2 to the power 0 by 2 divided by root 2, that is equal to 1 by root 2. Okay, so in this way we got the third element h1 of 0 by 2. Similarly for h1 of 1 by 2, that is again here in this case the value of z is 1 by 2. Okay, so it won't be satisfying this condition, since we know that the z in the first interval, the z is strictly less than 1 by 2 and greater than 0. Okay, so that's why you should be going for the second interval now, where now the value of range of z is from 1 by 2 to 1. So it would be satisfying this range here. So that's why you should be taking our equation as minus 2 to the power p by 2 divided by root n. So minus 2 to the power p value is 0, 0 by 2 divided by root 2. Minus 2 to the power 0 by root 2, that is minus 1 by root 2. Like that we got all the four elements of the HAAR matrix H2, that is first two elements are the same, that is 1 by root 2, then this is 1 by root 2, and this is minus 1 by root 2. So here in this case all the four terms you could be taking 1 by root 2 common outside, and the left out terms are 1 1 1 minus 1. Okay, so this is our final 2 cross 2 HAAR matrix with the equations which for different intervals we have calculated for 2 cross 2. Okay, so hope it is clear. Now let us see for 4 cross 4. Okay, it's very easy. If you understand 2 cross 2 very well, easily you could be doing for 4 cross 4. In 4 cross 4 it is h4. Here in this case the value of n is equal to 4, and since n is equal to 2 power n, so that's why 4 is equal to 2 power n. So we know that 2 square is equal to 4. So our small n value should be equal to 2. Okay. So that's why they have written it as small n is equal to 2. So now H4, so it is a 4 cross 4 matrix where the Z value is from 0 by 4, 1 by 4, 2 by 4, and 3 by 4, and K values are 0, 1, 2, 3. Okay, so like that we have formed this matrix here. In this, as I've already told you, for k is equal to 0, that is the first row elements, these all four elements are having the same answer. That is, we should be writing directly 1 by root 10. So 1 by root 10, the value of capital N is 4, so 1 by root 4. Okay, so these four values are directly written as 1 by root 4. Now for other values of k, that is k equal to 1, 2, 3, you should be finding 1 by 1. Okay, so for k equal to 1, so in from the table we know that for k equal to 1, the values of p and q are 0 and 1. So that's why I have written it as p equal to 0 and q equal to 1. First, we have two intervals to be checking for z value, in which value the z is getting ranged. So let us check that first. Interval 1, that is q minus 1 divided by 2 power p, less than or equal to z less than q minus half divided by 2 power p. In this case, the value of q is 1. Take that 1 minus 1 divided by 2 power 0, since p value is 0. And here we have 1 minus half divided by 2 power 0. 1 minus 1 is 0, so that's why it is 0. And half divided by 1 is half. So this is the first interval range, that is 0 is less than or equal to z less than half. Okay, so interval 2, q minus half divided by 2 power p less than or equal to z less than q divided by 2 power p. Again, substitute the value of q as 1 minus half divided by 2 power 0, and here 1 divided by 2 power 0. So final interval would be from z ranging from half to 1. Okay, so we have got the two intervals here. Now find the values of h1 of 0 by 4, h1 of 1 by 4, h1 of 2 by 4, and h1 of 3 by 4. That is the second row elements. Okay, this is the second row elements for k equal to 1. So one by one you find. First is h1 of 0 by 4. So these are all in the brackets, all the values of z here. So here h1 of 0, 0 by 4 is 0. So it would be satisfying this interval here, right? That is z is between 0 and 1 by 2. So for this interval we know that the equation you should be taking it as 2 to the power p by 2, right? So that I have taken it here, divided by root n. So in this case the value of n is 4, so root 4. So 2 to the power p, the value of p you should be taking it as 0 for k equal to 1. So that is 0 by 2 divided by root 4. 2 power 0 by root 4, that is 1 by root 4. Okay, so this is for h1 of 0. Next, for h1 of 1 by 4, again this is the value of z 1 by 4, and again it satisfies this interval only, because in this interval the z is between 0 and 1 by 2. It would be coming in this interval only, so that's why you should be taking again the value as 2 to the power p by 2. Do this necessary simplification by substituting the value of p, and again we got the answer as 1 by root 4. Again for h1 of 2 by 4, again here you see here, if you simplify this 2 by 4, it would be again 1 by 2. So now 1 by 2 is not in this range because it is strictly less than 1 by 2. Okay, so that's why it would be coming in this range now, where z is between 1 by 2 and 1, less than or equal to 1 by 2, and less than 1. Okay, so that's why you should be taking now minus 2 to the power p by 2 divided by root n. So minus 2 to the power 0 by 2 divided by root 4, that is minus 1 by root 4. Next, for h1 of 3 by 4, again 3 by 4 lies in this range. Take that minus 2 to the power p by 2, second condition, and substitute it, and we would be getting our answer as minus 1 by root 4. Okay, like that we got all these four set of values in the second row elements. Now third row elements for k equal to 2. So for k equal to 2, you should be taking the values of p and q and 1 1 each. So two intervals, again you do the simplification. First interval q minus 1 by 2 power p less than or equal to z less than q minus half divided by 2 power p here. Okay, substitute the value of q, in this it is equal to 1. So 1 minus 1 divided by 2 power 1. Okay, and here 1 minus half divided by 2 power 1. Solve it. Since 1 minus 1 is 0, so here we would be getting 0 less than or equal to z less than 1 minus half, that is equal to half only. So half divided by 2, that is equal to 1 by 4. So this is the one range, that is for interval 1 for k equal to 2, that is z is between 0 to 1 by 4. For interval 2, again do the simplification based on the condition q minus half divided by 2 power p, and here we have q divided by 2 power p. Substitute the value of q. Okay, and this is the second range we got for z, that is 1 by 4 is less than or equal to z less than half. So these are the two ranges here for z. Based on that, you should be calculating for H2 of 0 by 4, H2 of 1 by 4, H2 of 2 by 4. So this is 2 by 4, and H2 of 3 by 4. Okay. So now you see here H2 of 0 by 4, that is H2 of 0. So here the value of Z is 0, and it is ranging in the first interval. Okay. So that's why our value would be, should be taking it as 2 to the power P by 2. So substitute that the value of P here, it is equal to 1. Okay. So substitute 2 to the power 1 by 2 divided by root 4, and 2 to the power 1 by 2 can be written as root 2. So root 2 by root 4. Okay. That is whole root 2 by root 4. This is the first answer. Next, for H2 of 1 by 4. So now 1 by 4, in the first interval it is not satisfied because it is strictly less than 1 by 4. So come to the second interval. So in this interval the value of Z ranges. So that's why now we should be taking minus 2 to the power P by 2 divided by root n. So here the substitute the value of P as 1, and here we would be getting our answer as minus root 2 by root 4. But if you check for 2 by 4 and 3 by 4, in both these intervals, here if you solve for 2 by 4, it is equal to 1 by 2, and here we have 3 by 4, which is greater than 1 by 2. But the interval of Z are only ranging till 1 by 2. Okay. But if we have the values greater than 1 by 2, it is the third condition would be satisfied, that is it would be equal to 0, right? So that's why directly automatically you should be writing h2 of 2 by 4 and h2 of 3 by 4 is equal to 0, because it is not in the Z value is not in the range which we have simplified. Okay. So that's why h2 of 2 by 4 and h2 of 3 by 4 are directly equal to 0. Similarly, solve for the fourth interval. In the fourth interval, we should be taking the value of k as 3, p is equal to 1, and q is equal to 2. Okay. First interval again, q minus 1 by 2 power p less than or equal to Z less than q minus 0.5 divided by 2 power p. And take the value of q as 2, 2 minus 1 by 2 power 1, and here 2 minus 1 by 2 divided by 2 power 1. So 2 minus 1 is 1, and here we have 2 power 1 is 2, so 1 by 2. And here we have 2 minus 1 by 2, that is, if you solve it, you would be getting it as 3 by 2 divided by 2, that is equal to 3 by 4. So this is one range, that is 1 by 2 less than or equal to Z less than 3 by 4. And for interval 2, it is 3 by 4 less than or equal to Z less than 1. Okay. Now solve for H3 of 0 by 4, 1 by 4, 2 by 4, and 3 by 4. Okay. So now you see here, H3 of 0 by 4 is 0. Why? Because for Z here, we have the value of Z as 0, but here in these two intervals, we don't have the range of Z only. So that's why for 0 by 4 and 1 by 4, again for 1 by 4, since it is less than half, since the value of Z is ranging from 1 by 2 to 1 only. Okay. The before values and after values are Z are invalid, so we should be taking it as the third condition 0. Okay. So these two values are 0, and for 2 by 4, you see here H3 of 2 by 4, you could be writing it as H3 of 1 by 2. So 1 by 2 is in the first interval range, that is this range. So that's why you should be taking 2 to the power p by 2 divided by root n. Solve it, and you'll be getting our answer as root 2 by root 4. And for 3 by 4, again it is in this range, second interval range, that is minus 2 to the power p by 2, and we would be getting it as minus 2 by minus root 2 by root 4. Okay. So like that, our matrix you would be getting like this. In this 1 by root 4, you take it common and write the remaining terms. Okay. So this is our final H4 matrix for 4 cross 4. So this was a bit lengthy problem, but if you understand each and every step very carefully, easily you could be solving this. Okay. So that's all for this video, guys. I know that this video has become a bit long because I wanted to explain this concept in detail. So that's why I took this long. So hope you have watched this video till the end, understood this HAAR matrix problem. Please like, share, subscribe to our channel, and keep supporting us. Thank you.